Imagine gazing out into the endless universe surrounded by countless stars and mysterious worlds, yet among them all, one planet shines with vibrant blue and green, a world alive with wonder. This is our home, Earth. This, of course, is our home. This is the Earth. What is it that makes our planet so profoundly different from its neighbors? Imagine our solar system as a vast cosmic neighborhood. At its center is a star, our sun, a colossal furnace of burning gas that floods the system with light and heat. Around it, planets travel on their immense looping paths or orbits. Some are very close to the sun, like Mercury, a world baked to extreme temperatures where any water would instantly boil away into space. Others are far, far away like Neptune, a distant icy giant plunged into a deep permanent freeze. Within this grand celestial arrangement, Earth occupies a truly privileged position. We are the third planet from the Sun, orbiting at an average distance of about 150 million kilometers. This distance is absolutely crucial. It places our world within a very special region known as the habitable zone, or more affectionately, the Goldilocks zone. Just like the porridge in the children's story, this is the region where conditions are not too hot and not too cold. They are, in fact, just right. Our planet is a sphere of truly immense proportions, though it may not always feel that way from our perspective on its surface. If you could measure it from one side to the other, passing through its very center, you would find it spans a distance of nearly 13,000 kilometers. It is a world large enough to have a significant gravitational pull, and this is a critically important feature. Gravity is the invisible force that holds everything together. It is what keeps the oceans from floating away, what holds the very air we breathe close to the surface, and what anchors us firmly to the ground. The Earth is not just a uniform ball of rock, it is composed of many different materials, arranged in a series of distinct layers, a bit like an onion. The elements that make up our world are a legacy of the swirling cloud of gas and dust from which our solar system was born billions of years ago. During its fiery, youthful stage, the heavier materials sank towards the center of the planet, while the lighter materials floated towards the surface. This process, known as differentiation, is what created the fundamental structure of the Earth that we know today. Let us now embark on an impossible journey, a descent deep into the heart of our planet, to a realm of unimaginable pressure and heat. At the very center of the Earth lies the core. This is the planet's innermost secret, a sphere made almost entirely of metal, primarily iron and nickel. The core itself is divided into two distinct parts, a solid inner core and a liquid outer core. The inner core, despite being hotter than the surface of the sun, is squeezed into a solid state by the crushing weight of the entire planet pressing down upon it. Surrounding this solid sphere is the outer core, a vast churning ocean of molten iron and nickel. This layer is in constant turbulent motion. The immense heat radiating from the solid inner core causes the liquid metal to move in great swirling currents, a process known as convection. This dynamic liquid layer is a critical engine room for the entire planet, and its existence has consequences that reach far beyond the Earth's depths. The core is, in essence, the planet's furnace. This hidden metallic heart is far from being a static feature. It is a place of immense energy and activity. As we ascend from the planet's metallic core, we enter the next great layer, the mantle. This is by far the thickest section of the Earth's interior, a vast region of hot, dense rock that makes up more than 80% of our planet's volume. The mantle is not quite a liquid, nor is it entirely solid. It's best described as a solid that can flow, but only very, very slowly over immense geological timescales. Imagine a substance like extremely thick tar or honey. Over millions of years it can move and circulate. The mantle is in a state of constant slow-motion turmoil. This relentless churning in the mantle is the engine that drives plate tectonics. The rigid outer layer of the Earth is broken into massive plates, and these plates are carried along on top of the moving mantle beneath them. Where the mantle currents rise, they can push plates apart, creating new crust at mid-ocean ridges. Where the currents sink, they can pull plates together, causing one to slide beneath the other in a process called subduction, which can form deep ocean trenches and chains of volcanoes. The slow dance of the mantle is responsible for the drift of continents, the raising of mountain ranges, and the awesome power of earthquakes and volcanic eruptions. Finally, after our long journey up from the planet's center, we arrive at the surface layer, the ground beneath our feet. This is the Earth's crust, and compared to the other layers, it's incredibly thin. It's like the delicate skin of an apple, a fragile shell of solid rock enclosing the vast mantle and core beneath. The thickness of the crust varies from place to place. Beneath the great oceans, it can be as thin as 5 kilometers, while under the towering mountain ranges that form our continents, it can be up to 70 kilometers thick. The crust is not a single unbroken shell. As we have learned, it's fractured into a number of enormous pieces, known as tectonic plates. These plates are in constant slow motion, moving at about the same speed that your fingernails grow. Over the vast expanse of geological time, this slow movement has had dramatic effects. It has carried continents across the globe, opened up new oceans, and crashed land masses together to build colossal mountain chains like the Himalayas. This process, plate tectonics, is the grand architect of our world's geography, continually reshaping the map of our planet. Surrounding our solid planet is something just as vital for our survival, yet it's almost invisible to us. It's the atmosphere, a multi-layered blanket of gases held in place by Earth's gravity. This envelope of air is the reason our planet is not a silent, airless world like the moon. It's composed primarily of nitrogen, which makes up about 78%, and oxygen, which accounts for about 21%. That oxygen is the gas that we and most other animals must breathe to live. The remaining 1% is made up of a mixture of other gases, including argon, carbon dioxide, and water vapor, each playing a subtle but important role. The atmosphere does much more than just provide us with air. It acts as a crucial protective shield. It filters the sunlight that reaches the surface, and in a layer high above us, known as the stratosphere, it contains a special form of oxygen called ozone. This ozone layer absorbs most of the sun's harmful ultraviolet radiation. Without this protection, the sun's rays would be so intense that they would make life on land impossible. Our atmosphere is also the engine of our planet's weather and climate. The sun's energy heats the Earth's surface unevenly, warming the equator more than the poles. This difference in temperature causes the air to move, creating winds that circulate around the globe. Beyond the air we breathe and the ground we walk on, Earth possesses another completely invisible layer of protection. This is the magnetic field, a vast bubble of magnetic energy that surrounds our planet and extends tens of thousands of kilometers out into space. This field is generated deep within the Earth by the churning of the liquid iron in the outer core. The movement of this molten metal acts like a giant electrical generator or dynamo, creating powerful electric currents which in turn produce the magnetic field. Our sun is not just a source of light and heat, it also constantly sends out a stream of charged particles known as the solar wind. This is a powerful and destructive force that travels through space at hundreds of kilometers per second. The Earth's magnetic field, also called the magnetosphere, acts as our planet's shield. It deflects the majority of the harmful particles of the solar wind, forcing them to flow around the planet rather than impacting it directly. We can sometimes see a beautiful manifestation of this interaction, when some of the charged particles become trapped in the magnetic field and are channeled towards the north and south poles. They collide with gases in our upper atmosphere. This collision causes the gases to glow, creating the spectacular shimmering curtains of light known as the aurora borealis and aurora australis, the northern and southern lights. Every year, our planet completes one full journey around the sun, a vast circular path that takes approximately 365 days. This orbit is the reason we have years. But you know, it's not the orbit alone that gives us the familiar rhythm of the seasons: spring, summer, autumn, and winter. The true cause of the seasons is something more subtle. The Earth is tilted. It doesn't spin straight up and down as it orbits the sun. Instead, its axis, the imaginary line running through the north and south poles, is tilted at an angle of about 23.5 degrees. This axial tilt means that for part of the year, the northern hemisphere is tilted towards the sun, while the southern hemisphere is tilted away. During this time, the sunlight hits the northern hemisphere more directly, delivering more concentrated energy. The days are longer, the nights are shorter, and the weather becomes warmer. This is summer in the north. As the Earth continues on its year-long journey, its orientation to the sun changes. Half a year later, the situation is reversed. The southern hemisphere is now tilted towards the sun, experiencing its summer, while the northern hemisphere is tilted away, experiencing its winter. In between these two extremes are spring and autumn, the transitional seasons when both hemispheres receive a similar amount of sunlight. Hanging in our night sky is a familiar and reassuring presence, the moon. Our planet's only large natural satellite, the moon is a silent, cratered world, devoid of air, water, and life. Yet, despite its barren nature, it has a profound and steadying influence on the Earth. Its most noticeable effect is on our oceans. The moon exerts a gravitational pull on our planet, and because water is fluid, it can respond to this pull. As the Earth rotates, this gravitational tug from the moon creates a bulge in the oceans, leading to the regular rise and fall of the sea level that we call the tides. Beyond the tides, the moon plays another, perhaps even more critical role for our planet. It acts as a stabilizing anchor for Earth's rotation. Our planet, with its 23.5-degree tilt, is like a spinning top. The gravitational pull of our large moon helps to prevent this top from wobbling too erratically. Without the moon's steadying influence, the Earth's axial tilt could vary wildly over long periods of time, swinging between no tilt at all and a much more extreme tilt. Our constant companion is more than just a beautiful object in the night sky. It is an active participant in the Earth's systems, a gravitational partner that creates the ocean's pulse and helps to keep our world on a steady, even keel as it journeys through space. We have journeyed from the fiery heart of our planet to the highest reaches of its atmosphere and beyond. We've seen how a remarkable series of fortunate circumstances have come together to create a world capable of supporting life. It's a planet of the right size, in the right place, made of the right ingredients. It has a molten core that generates a protective magnetic shield, an active mantle that shapes its surface, and a thin, precious crust that serves as the foundation for all ecosystems. It's wrapped in an atmosphere that provides air, water, and warmth, and it's tilted just so, creating the gentle rhythm of the seasons. Each of these features is remarkable in its own right. But what makes Earth truly extraordinary is that it has them all. It's this unique combination that has allowed life not just to survive, but to flourish in breathtaking diversity for billions of years. From the deepest ocean trenches to the highest mountain peaks, life has found a way. It has adapted, evolved, and transformed the very face of the planet. Life is not just a passenger on Earth, it is a powerful geological force. In the vastness of the known universe, we have not yet found another world like ours. We've looked at our neighbors in the solar system and found them to be hostile and barren. We're now looking at planets orbiting distant stars, and while we may one day find another world with some of the right conditions, we have no guarantee that we ever will. For now, and for the foreseeable future, Earth is the only home we have. It is a single, interconnected system, and our own species is now the most powerful force acting upon it. Understanding our planet, its history, its systems, and its fragility, is therefore one of the most important tasks we face. We are the custodians of this precious blue marble, the only world we know that is bursting with music, with color, and with life. We must cherish it, protect it, and work to understand its secrets. For in doing so, we ensure a future for all the wonders it holds.